Welcome to SQVe Structural Summit. We are very much thankful of you for participation in the live discussions. Please subscribe to our YouTube channel of SQVe Academy and press on the bell icon. You will receive notification for the future events when we go live. Also, kindly like and share the video with the engineers in your network so that more numbers of engineers may be benefited. We are planning to come up with more and more important and informative videos. To support the initiative, you may join our YouTube channel of SQVe Academy with nominal monthly subscription. In return, you will get access to member-only videos at YouTube and the other perks. The subscription can be cancelled at any time. Step-by-step approach to join the YouTube channel is mentioned on the screen. For any doubts, you may get in touch with us through email address. Thank you.
Hello, welcome to this session number 90 of SQVe Structural Summit. And today we are going to have a brainstorming discussion on IS 875 Part 3. So up till now, we conducted so many sessions on different draft codes, but this is a different session. So our aim for this session is to collate queries in advance because this code is under revision. So with us today, we have Dr. Abhay Gupta as well as Dr. P. Hari Krishna. We can say the national level experts in the wind engineering, right? So I'll hand over now to Dr. Abhay Gupta to set context of today's talk. Yeah.
Thank you, Bhavin. Good evening, friends, and good evening, Dr. Hari Krishna. This is a different kind of session. I would just like to confirm if in the participants, Dr. N. Subramaniam has also joined the link. Can you check, sir?
Yeah. He's joining regularly our session. So maybe after let's say a few minutes he'll be there.
That's something very good. He specifically mentioned that he would be joining. So Subramaniam is a well-known structural consultant, not only consultant but structural mentor also. Friends, as we all know, IS 875 is the loading code. Bhavin, there is an echo.
Yeah, I'm getting echo. Yeah. Let me put the mics off. Yeah.
So IS 875 has several parts which deal with the loading on the structures. Part 1, 2, 3, 4, and 5. We are currently in process of reviewing all these codes and coming up with the latest updates on these as revisions. This particular session is dedicated toward the wind effects on buildings and structures, and it will be a good brainstorming session, so that during the process, when already the meetings of the committee, of which Dr. P. Hari Krishna is the convener, are undergoing, we can take up the queries from the users. Sir, welcome, good evening, and Dr. Subramaniam is there. So we are happy to have you, sir, and your inputs would certainly add a lot of value. Thank you. Friends, this IS 875 Part 3 was earlier a 1987 version, and then after 28 years, we had 2015 version. From 2015 version to now 24, that is 9 years already passed. Already there are 2 amendments in that, and much of work is being carried out across the globe about the more understanding of this particular phenomena of wind effects on structures. This particular code covers structures, low rise, high rise, as well as some special structures like open lattice structures, hoardings, water tanks, covered structures, industrial structures with multiple array, and so many other things. Each one of the participants in this program today is using this code in one or more projects. While doing so, as we all know that wind is a very random phenomena, and whatever results are presented about the pressure coefficients, force coefficients are based on the experimental studies conducted. So Each and every case is not included in the code, but there's a wide range. Moreover, when we try to estimate the wind forces, understanding the terrain category, understanding the turbulence characteristics, understanding the pressure coefficient, internal and external, all those things are very, very important. And we have to do engineering judgment at many times. Friends, this session we would like to invite or listen from you about your difficulties faced during usage of this code, and from your inputs we would like to add in the put in the codal committee about the new aspects to be added or refined. Dr. Harikrishna will tell you more about what are those specific points on which we are deliberating these days. Dr. Harikrishna, please.
Yeah, good evening to everybody. First of all, I would like to thank the organizer for giving me this opportunity. So the first thing is that this revision of IS 875 Part 3, the code or the subject is itself is not a conventional engineering subject actually. And first and foremost, I would like to raise some points that we have to acknowledge that in India, very few institutions are offering wind engineering as a elective. So this makes the understanding of the wind load calculation is something like until you understand, it will look like a something like a maze or a puzzle kind of thing. But once you understand it, you can see through any problem and try to interpret it properly. So I just want to give this brief background. And then when it comes to IS 875 Part 3 revision 2015, so actually 1987 version is the one with well designated Part 3 wind loads in 1987, and subsequently it was revised in 2015. So what is the change from 1987 to 2015 is that one is the major thing is that basic wind speed map, because we had additional wind speed data from IMD stations, meteorological stations. So with that, additional analysis was carried out, and revision in the map took place. But 2015 published map is old one, but amendment is given in 2020. So that is the NBC 2016 wind speed map. And apart from that, the changes, major changes took place in 2015. One of the things is that addition of crosswind force spectra for tall buildings. That is one of the major additions. And also one of the major change or modification is that the calculation of gust factor. Earlier, the formula is given with many graphs which are logarithmic in nature. So people have to interpolate logarithmically from the graphs, various graphs given in that 1987 version. Whereas in 2015 version, the graphs were taken away and they were replaced with numerical formulas, where in which interpolations and other things are minimized. So this is what happened in 2015. So now we are in 2025, and BIS is trying to revise this version. And one major thing now I just want to tell is that one is obviously the additional data is available. So that data also will be included in the basic wind speed map revision. So while revising basic wind speed map, first and foremost is that we have taken a rationale that if suppose after adding the data and re-evaluating the values, if suppose old values are on the higher side, we are going to retain it. Suppose re-evaluated values are more than what is existing, then we are going to upgrade it. So that is the design rationale adopted policy. Policy is adopted. And second thing is that whatever is 1987 version and 2015 version, which are common, is that major portion of the code is consisting of aerodynamic coefficients, which we call it as pressure coefficients and force coefficients. So those coefficients are same either in 1987 version or in 2015 version. So the major change we are expecting in the revision now is that we want to upgrade these information in line with various international codes of practice, and also in India we have done a lot of R&D projects on wind effects on buildings and structures at Structural Engineering Research Center, Chennai, which is a premier institution under CSIR. And this campus has established a boundary layer wind tunnel facility way back in 1992, and that is the first department in India, and even now also I would say the only department which is focusing on wind engineering research, basically research and consultancy. Whereas there are other institutions are also pursuing, but wind engineering core expertise is not there. It is supported by aerospace engineering people. So what in this new revision we are looking is that, as I said, that aerodynamic coefficients need to be revised. Why it has to be revised? The reason is that whatever current version is there, 1987 or 2015, they were all borrowed from British standards way back in 1980s and 70s. The internal investigations were carried out on buildings and structures models, but the simulations corresponds to like uniform, smooth, streamlined flows. There is no turbulence flow simulation facilities were not there at that point of time. Hence, whatever results available at that point of time were adopted in design practice. So in India, we are still, holding our in practice is that those coefficients are only in practice. Now we are revising it. Now we want to change it to the coefficients which are derived based on wind tunnel experiments conducted under turbulent flow conditions. So that is the major change. So in this, the sources are that current international standards. Sources is one of the things. Second is that in SCRC Chennai, we have conducted many R&D projects in the last two decades, and those results we will try to compile them and then also submit to BAS for deliberations. And apart from this, one more revision is that these crosswind force spectra and additionally torsional force spectra are also going to be added in line with international codes of practice. But what we notice is that across different international codes of practice, there are some commonalities are there, there are some deviations are there. So we will be analyzing or deliberating on those commonalities and deviations, and the best form we want to recommend for this revision of IS 875 Part 3. So broadly, I want to state this. Thank you.
One more point for the information of all our participants, I would like to add that along with 875 Part 3, there is one more very useful document which is under preparation and will come soon. Guidelines for wind tunnel testing of buildings and structures. As Dr. Harikrishna said, there is a wonderful facility at SCRC Chennai. There are some more facilities available in the country and international also. But as such, our users are not clear about when they float an inquiry for the wind tunnel testing, because the new code IS 16700 for tall buildings makes it mandatory for some structures. But otherwise also in many of the low-rise structures and some other structures, it is very necessary to conduct a wind tunnel testing. So having a guideline will certainly help the user to formulate the test SOP, and then for the wind tunnel operators also to conduct and submit the reports accordingly. So this is an additional information. We can now go to the IS 875 Part 3 and see what is there and where all users are facing difficulty.
Okay, so let me put 875 on the screen, right? And then we can start the discussion.
Yeah. Whether full screen is shared? Yes. Just zoom in a bit. Make it a little bigger. Good. Friends, just if you read the foreword of this code itself, just go up, please. Here, just below, last para, below this load list, below this. Yes. In this current revision, the committee recommends the following. So these are the points which just now Dr. Hari Krishna has mentioned. So I will always recommend or advise users, whenever there is a new version of the code which comes out, you should look for this particular para in the forward. This gives a summary of what all changes have been done in the document. This is a good thing. Okay. So when this next version will come, again there will be a write-up here that what all changes have been done. Go down. These basic things will remain same. Scope and application. While making the final draft, we will see if there is any word, any statement is to be changed. But otherwise, more or less this introduction, reference, terminology is going to remain same. Any confusion to any user here, we can discuss about any of these terminology, or if they want any new terminology to be added. एक्सेल शीट में ऐसा कुछ है तो अपन देख सकते हैं. थोड़ा और बड़ा करेंगे. या लेट्स गो टू द टॉप. Wind load calculation on transmission or communication towers. Dr. Hari Krishna, would you like to elaborate this particular, that how is this covered in 875? You are muted, sir. You are muted.
Yeah, 875 part 3 is more like a parent code, and there are additional codes of practice depending upon the type of structure. For example, 802 IS 802 addresses transmission line towers, and very recently one more code has come that addresses the communication towers actually. So the parent code remains IS 875 part 3, but there are specialized clauses for depending upon the type of structure. These additional codes of practice are there. So transmission tower is 802, and communication tower, I forgot the number, it is very recent one, 16834 or something like that.
Oh, that's available. And very good thing is that all the codes are available for free download for the users nowadays from the BIS website.
Yes. You just need to register and then
Yes.
download the things.
Regarding the item number 5, Gandhi Shri Krishna, wind load calculation of 875. I'm not going to deliberate on this much, but just for information, there is a handbook which is already existing, SP64, and this updated version of that handbook will also be prepared simultaneously as the revision in the code takes place. So that handbook will provide you with the proper simplification for explanation of the clauses and even the wind load calculation for various structures. It will be there. Coming down, which permeability is more important in all three permeabilities? All three means there are two permeabilities. Is there a third one, Dr. Hari Krishna?
Yeah, I mean, it is not like which is important actually.
Okay, 3
It
means
is
medium, low, medium, high.
yes. So in reality, you have to the as a design engineer or the end user, the building specific permeabilities will be there. So it is not about which is important. So you have to choose the category based on number of openings in the building wall.
The permeability has to be calculated based on the area of the opening on walls to the total area of the walls. Actually, to explain it more, the wind flow pattern inside the wind pressure inside the enclosure changes depending on the area and opening placement of the openings, depending on the whether the wind is leaving from the structure or entering in. That is there. That is why there are plus and minus, both the values are there. Pressure will be there and suction will also get created, and the value whether it is low, medium or high depends on the area of the openings. So more detail about this, when you actually calculate, you will get to know. But you have to consider the entire area of the openings to entire area of the walls. It is not for a specific wall. This is for the entire enclosure.
Yes. But the assumption is made in the code of practice is that it is something like worst case scenario. That means suppose there are 4 walls will be there. So one side of the wall opening got damaged like just like during cyclones. The other sides walls openings are not got damaged. So that is the worst case scenario, and that worst case scenario is assumed, and then corresponding values or magnitudes of coefficients are given in the code of practice. Whereas in reality, you can expect that the damage can happen to the openings during a cyclone, not necessarily only one wall. Other walls openings are also can get damaged, but for conservative design purpose, it is assumed that the opening on one wall is got damaged and all other 3 wall openings are intact. That is the assumption.
Now, point number 13, like the ductile detailing, is there any specific design concept for wind resistance? See, basic philosophical difference between seismic and the wind is that seismic, you go into the non-linear range of the behavior, while wind, which is more frequently occurring, a daily phenomena, your structure behaves elastically. This is the difference. So in wind design, there is no ductility concept or there is no ductility requirement is there. Okay. Wind load coefficient for individual sections. It's there already, and more or less no change I expect will be there. K4 factor. Yes. K4 factor. Dr. Krishna, you can elaborate more on this.
Yeah.
Can we
So
see that, Bhavin, can we see that clause K4 factor? नीचे आइए. Next.
yeah. So this is another factor which was introduced in 2015 version, which I didn't mention in the earlier remarks. So this is another factor which was introduced in 2015. It is basically limited to the coastal regions of India and mostly on the east coast and also Gujarat coast. So about 60 kilometers region from the right from the coast, this factor has to be applied. Only thing is that the magnitudes are derived based on cyclone wind speeds data, and the factor derived on a design basis like a rational is a factor of 1.3 is arrived, and that is recommended. Only thing is that here also one more rational is adopted is that this 1.3 needs to be applied for post-cyclone important structures. So we don't want to tax this factor. Suppose 1.3 factor on velocity means forces will be to the order of increase 69%. That means around 70% increase in the loads. So this is not what you call warrant us to adopt it for every building and structure, but this 1.3 is recommended for post-cyclone important structures like cyclone shelters, hospitals, schools, communication towers, etc. That means these structures are not expected to get damaged during cyclones, so that they function even after the cyclone. That is the idea. Now, for general buildings and structures, it is still recommended only to take only one. So that means as good as any normal non-cyclonic regions. That means even there is a damage levels are expected during cyclone, but they are acceptable for these all kinds of general structures. Now between 1.3 and one more factor is introduced, that is 1.15, which is again a ratio between 1.3 and 1. And again, it is a simple design rationale, and it is recommended for industrial structures. So the reason is that industrial structures are the ones which collapse or get damaged during cyclones, and they have post-damage implications will be there. So that is the reason this additional class is introduced. But in next revision, what we are trying to do is that we will be maintaining these classes, but we will be adding other typology of structures, because we are getting feedback from the end users that where do the tall buildings fit. So it is not explicitly given where the tall buildings are there. So where the chimneys are there, where the communication towers is there, transmission line towers, where is it there. So like that, a lot of feedback is there. So keeping those feedback, we are going to cover as many typologies as possible in this classification of K4 factor.
Good. Local coefficient considered for design of purlins. Good. It is when you consider the factor, the area averaging factor in the code, you automatically get to these values, because purlin girds, they cover a smaller area, while when the same force get transferred on the main structure, it is from a larger number of elements, so there the net effect is lesser. So for the design of main frame, the area averaging factor will reduce, whereas for the local members it will be higher. Moreover, for purlins girds near the edges, corners, ridges, peaks, where the local peak pressure coefficients are given, we should check the design for those local peak pressure coefficient, either by increasing the section or by reducing the spacing of the members in those zones. That care should be taken, because otherwise the cladding starts coming out from that corner only. Okay, go down. Towers already explained. There are two separate codes. Teaching profession, why to agree with the latest in the wind engineering. Yeah, these are good documents for you, this code and the handbook and some more structure specific codes. But occasionally there are some short-term programs which are being run by SARC Chennai and under Dr. Krishna and other team members. So whenever you get some information of that kind, you can keep in touch and make good use of them. Gust loading is there already as far as the long wind is concerned. A crosswind is also there, and as such, we do not expect any change in those formulations which are given, except Dr. Krishna, what about the cross? Are we going to make some changes in the crosswind? Because we are facing difficulty. As a user, I am also facing difficulty with the crosswind.
Yeah, I mean, crosswind is more like a wide open challenge actually. So that is the reason most of the codes, for example, if you take Australian code, ACE 7, they clearly tell that we don't make any recommendation for crosswind load calculation, but we recommend to approach the database assisted design approaches. That means there are some authentic websites maintained by reputed American universities, and you approach that website, and then whatever results provided in that website, you can borrow and use it for your design load calculation. So that is the case of ASCE. And whatever current version of IS code provisions are for the crosswind spectra, they are actually borrowed from Australian code, but they are very limited cases only. But if I take parallel reference, Japan code and ISO code, they are well ahead in relative to other codes. More rectangular building cases were tested in Vinternal, and the codal recommendations cover at least a wide range of cases. Unlike Australia code,
Yeah.
Australia code is very limited.
Which are those documents you just mentioned?
Yeah.
ISO and Japan code.
Yes, wind load code.
Wind load. So whether this ISO wind load code is available to public?
No, it is not available to public. You can procure it. You can procure it by purchase or something like that.
Okay. So what is its number? Can you give that number?
Yeah, 1 second.
Because that should be because the crosswind provisions in the current IS code, as you said, are
Yes.
very much limited. Just
Yes.
one terrain category and two types of shapes. So
Yeah.
it's very significantly with the change in the geometry, change in the height ratio and all that.
Yes. So it is ISO 4354.
ISO 4354.
And
Okay.
other one, Japan code is AIJ.
AIJ.
Yeah. It is recommendations for loads on buildings.
Okay. So these two documents can be referred by users for more clarity on the phenomena. Okay.
Yeah.
Thank
And
you.
in the current revision, we are going to take help of these two codes and look at the commonalities and better provisions, anything is there. We will be adopting those things. And apart from that, I want to add that at SCRC, we have taken up a new, ongoing project by adopting machine learning techniques. We want to provide a user-friendly solution for this complex phenomena that is crosswind core spectra.
Excellent. Excellent. Thank you. We can also include the names, numbers of these reference documents in the forward when we come out
Yeah.
with the
Sure,
news.
sure. Yes.
Next, no specific know about wind calculation of roof shed. That is a separate thing, not the. It's already there. But sir, maybe my question is not so good, but we want to discuss what will be the effect of wind load on a building made of TMT bars and a building made of FRP bars. Friend, as such, no effect because wind doesn't affect, doesn't get changed because of the internal reinforcement nature. It is basically a surface phenomena which depends on the geometry, shape, exposed area, all those things. So reinforcement will not make any effect. Are there any criterion to be considered specifically for wind load on PEBs? Many of the charts, tables given, they are applicable to the PEB sheds owing to their geometry, shape, size, dimensions. So you can very well pick up all the CPE, the external pressure coefficient, internal pressure coefficients from the current knowledge information available in the code. Advances in wind loads. As Dr. Harikrishna has said, there are many new things which have come up in last 10 years since this code was there, 2015, and we'll be trying to accommodate them. But if you want to know more about that, I think Dr. Harikrishna, if you can suggest some good reading material from where a user can get more information about the wind load. One is about the regular conferences.
Yeah.
So we have
Books were
national conference on wind engineering every year.
Yeah, very famous authors is the Simiu and Scanlan, and Professor Simiu. There are two books are there. Professor Simiu, American
SIMIU.
professor. Yeah, SIMIU. So there are two books published by him, and latest versions are the preferred ones. And apart from that, one more book by Professor John D. Holmes, Australian professor.
Oh, yes.
So these two books are, preferred.
But I think Australian handbook is also a very good document.
Yes, yes, it gives with examples and concepts behind the clauses available. Yes.
And there is an annual wind engineering conference happening in India. This time in November, it is going to be in VNIT Nagpur. And so that annual event attracts many good people from across India and outside also. So you can certainly participate. Mr. Rajan, I'll raise at the time of meeting. Please type your queries and then we'll see them.
Sir, parallelly there are queries are being typed in the chat box parallelly. Sri Subramanian Narayan sir
Yeah.
also already raised a few comments.
Okay, okay. Yeah. Yes, yes. SIMU is in NIST. Okay, and is one mathematical involved in complex. Yes, sir. Great. And estimation of K4 factor, there is another code, which is this 18315 is the new code for the estimation of K4. Is it that
Yes.
Arnab Sarkar
Yes,
worked on
yes,
this?
sir. Yes, yes. So it is actually the what was done is that whatever K4 factor right now in 2015 version is there, it was actually derived way back in 90s. Till that time, whatever data is there, that data was used and arrived at those numbers. And subsequently, recent past, similar exercise was carried out by Professor Arnab from IIT BHU. So it has corroborated or reconfirmed that those values still hold good with additional data available. So
Yeah.
that based on that exercise, which is actually sponsored by Bureau of Indian Standards, that exercise was sponsored, and subsequent to that exercise, a new code was introduced, 18315. So for the K4 factor, which is actually same as whatever is currently in practice, except that it is given in a formula form. That's all.
Saurabh Gupta is asking, there are many times when we see mix-up of code, IS wind with AISC design. In AISC design, due to 700 years, wind coefficient reduce in load combination. What we should practice and advise to those? What is this, sir?
Yeah, it is basically written period based handling of the information. So it is what is suggested is that if you are borrowing any information from any other standards, either you see to that these are given in that code, or you borrow it in such a way that commonalities should be there. See, for example, IS code recommends 50 years written period as the basic wind speed. So whereas other codes of practice, they use some codes recommend 100-year written period. So it varies from code of practice to code of practice. So, but what needs to be kept in mind is that if you are borrowing or doing exercise across different codes of practice, you have to be consistent. So the consistency is very important. So we should not pick and choose parameters and values from different codes and then try to evaluate and compare. I'm sure you will end up with a wide scatter.
Mr. VM Rajan has raised a very good point that for arriving mean wind speed and gust, IS 875 part 3 uses 3 seconds and 1 hour for static and dynamic. But as per Eurocode, 10-minute interval is used for both methods. Why so variation in our code?
Yeah, it is similar to written period, which are yearly basic things. The other one is that within 1 hour, wind fluctuates within 1 hour. So for that, there must be a reference um, uh, averaging period. We call it as averaging period. So since wind is a dynamic phenomena and a random phenomena, it continuously changes with time, but we should fix a value. For fixing a value, the reference is that one is at what height question should be, and second question is that average over what period. So these two questions should be kept in mind when we tell any number about wind speed. So the guidelines are that mean wind speed can be averaged between 10 minutes to 1 hour. So that is one guideline internationally. So you can choose anywhere between 10 minutes to 1 hour to address the mean wind speed. So IS code is 1 hour, Australian code 1 hour. Whatever point raised, it is 10 minutes is a particular code. There are other codes where they use 20 minutes also. So it is from code to code it will vary. But what you should keep that they represent the mean wind speed. And similarly 3-second gust. So that is short duration we call it. Averaging period is 3 seconds. So if you approach other international codes, you may hear or know or see other than 3 seconds, like 5 second or 10 second or 1 second also is possible. So like that, there are different notations and definitions are there. So you should compare oranges versus oranges only. You should never compare apples versus oranges. So if the codes are written period or the averaging gust periods are different, magnitude should not be compared. You should bring them to common platform. There are conversion factors available which you can adopt. If I want to derive 10-minute wind speed from 3-second gust, we can derive it. Similarly, if I know 10-minute wind speed, I can derive the 3-second gust wind speed. So you should bring to common platform, then only you can address from across international codes. Till that time, it is not recommended to compare any from one code to another code design wind loads.
Thank you. Harshal Goyal has raised a good point, which probably many of the users of tall buildings are facing. So we will take up this question when we reach to the tall building section. Okay, let's go to the Excel sheet again. Coefficient for CPI already explained. Should we apply separate load exposed columns in shed design? Could not understand what does this mean. Design for MS anchor for 70 width span, height 10 meter at end at 45. Not question not clear. Mahesh Acharya, gust wind calculation, how consider the interference factor? Yes, this interference factor was also introduced in 2015 code. Again,
Yes.
this is based on several wind tunnel studies and a zoning has been done under this. However, there is still a debate on this. So Dr. Harikrishna, can you please throw light? And with reference to Australian code, where they had these factors earlier and later they moved it to handbook, I think.
Yeah. So this wind engineering phenomena, wind phenomena and its effects on buildings and structures is like a open-ended puzzle actually. So we are trying to, it is like a genie, try to put it in a lamp, magic lamp kind of thing. So these course of practice are that we try to make that a kind of attempt to fit a genie into a magic lamp. So IS codes are more like magic lamps. So reality is that wide open of possibilities are there, but these code of practice, whatever recommendations given, are more like a indicative things. So you want to make some preliminary estimation of design wind loads for the building, like a project. If you want to take up a tall building project, so they need to have some preliminary estimation of the wind loads that will give an idea of what is the project cost so that they can make the quotations in the tender forms. So for that, these factors which are on the conservative side can be utilized. But if you want to be more realistic, I want to use the word realistic. So if you want to arrive at realistic values, you need to make the simulations in the wind tunnel with the realistic surrounding buildings and structures. Then only you can arrive at the which is more meaningful interference factor. But another thing in reality happens is that, for example, in 10 years, a new building may come up next to the existing tall building. So what will happen to the new building on the effect of new building on the existing building? So when the existing building when it was constructed, that new building is not there, so the interference factor, it could be a different magnitude. But now a new building is coming up, it has got an implication on the existing building. So this is a what do you call is a real challenge. People are raising those issues. Only thing is that what we can do is that redo the internal analysis of that tall building existing with the new building and verify whether any adverse impact is there or not. And once again, I want to tell that wind is an environmental load, which is not in our control. There are a lot of probability issues are there. Things may happen or may not happen during the lifetime of a building. So that should always be kept in mind. People assume that whatever is given in the code is like a deterministic. No, it is not deterministic. They are all probabilistic. There is a chance that they get exceeded, and there is a lot of chance that they don't get exceeded.
Dr. Subramaniam is saying, due to global warming, the wind loads are increasing worldwide. Will the new code increase the wind loads due to this? In fact, rain intensity is also increasing. I think there is a study, there is more data available from IMD, but how well the effect is captured? Dr. Harikrishna, do we have any information?
Yeah, I mean, it is a rapidly changing phenomena, this global warming or climate change impacts. If I take 1990 to 2000, if I take 2000 to 2010 and 2010 onwards, if I see Indian coast, especially if we see the cyclones, we hear very frequently that a cyclone formed and then crossing the Indian coast. So earlier between 2000 to 2010, I rarely heard about many cyclones. Very few are there. 2013, I remember one is there. 2017, whereas subsequently it is happening every year. Only thing is that the magnitudes may not be significant, but among the more the frequency, there is more chance of high intensity wind can happen. So now the point raised by Dr. Subramanian Narayanan is that how do we address it? So till the more reliable data is available, if I take the example of Australian code, they introduced one factor called the climate change factor. So it says that 1.05 you apply on the any design wind speed. So that means it is only rational. 1.05 is a just 5% increase. So it is just what we are trying to do is that if I estimate or if I choose higher wind speed or higher wind loads, it is basically you should understand that I am trying to minimize the risk. So if I take the higher wind speed or higher wind load, is that I am taking reducing the risk level basically. So people think that whatever wind loads or earthquake loads or any other environmental loads estimated through code, they are not the values. They are only probabilistic values. So whatever we try to choose higher values is something like on a conservative side so that I can reduce the risk. So if, for example, before the knowledge of wind engineering, there are a lot of tall buildings and structures like Eiffel Tower. They were all constructed before wind engineering as a specialization came. So how could have they constructed such an iconic tower and it is standing testing times. So the reason is that when the knowledge is not there, so we need to adopt some factor of safety, additional factor of safety to address the uncertainties. Sometimes these factor of safeties are called ignorance factors, basically.
Ignorance.
So similar way, this global warming, I feel that it is a rapidly changing phenomena. The data availability is more like a recent past kind of 10 years to 20 years. If I want to extrapolate with that limited data to 100 year or 50 year, so there is a reliability related issues are there. Till that time, people can adopt rational factors.
The next question from Mr. Mahesh Acharya is the crosswind calculation. How to get the value of CFS, crosswind force spectrum coefficient from the graph. Can we just see that crosswind force spectrum graph in the code? Yeah, it will be much below.
At the almost end.
Almost.
Before crosswind, because we are moving to that class, I think earlier one Sri Harshal Goyal, so
Harshal,
raised
yes.
this head on S.
Yeah, there is one picture here. Go up, go
Yes,
up,
yeah,
go up.
slightly.
Yes,
So
this
you
one.
can zoom this. You
Nice.
can zoom this.
Zoom in कीजिए.
Yeah.
Harshal
So
is
zoom this.
asking,
Yeah.
elaborate the difference between Z and S.
Yeah. So the S is, let us say that S is not there. First, you imagine that S is not there. That means S equal to 0, let us say. So it is more like my interest is that, see, this is like a cantilever structure which is vertically mounted. On this cantilever beam, wind is like a lateral. So if you imagine this cantilever beam in horizontal form, so the lateral load will be vertically acting. So this load, lateral load, which is temporally changing with both space and time. So it is a random phenomena. So from that, I am trying to get a peak load effect at the bottom of the building. So there will be a lot of correlation related issues. Things can happen in a localized manner. The peak effects will be localized, and reduced peak effects will be there at a global level. So to address that aspect, this factor small s is introduced. So let us say that if I make s equal to 0, it means that my point of interest is that at the bottom of the building, what should be the column size? So that is the focus. Let us say S
Foundation
is
force.
equal to,
Basically,
yeah,
foundation
and
force.
suppose S is not 0, but it is something like, let me take a value of 0.5 H. That means at the half the height of the building. So
Suppose
what
there is an
will
offset
happen
in the
is that,
building. Suppose the
yes, sir.
plan
So
section
if
is
I want
changing.
to design, yeah, if I want to design the column at the half the height of the building, I should substitute small s equal to 0.5 H, and my load distribution will come from top of the building to that 0.5 H level. So your lateral load distribution, if S is non-zero, let us say 0.5 H, then the load distribution will be from the top of the building to the 0.5 H level. So you take that load distribution and you redo the structural analysis. From that, you get the column forces at 0.5 H level. Then you design that column. Suppose my interest is at, let me say, 0.7, 0.25 H. Then I have to substitute small s equal to 0.75 H. If it is 0.25 H, I should substitute column at the level of 0.25 H I want to design. Then I should substitute 0.25 H. So that is the thing you should keep it. Z, small z is more like a variation of load along the height. If suppose small s is equal to 0.5 H, the small z will vary from 0.5 H to full H, 1 H. So your load distribution varies. That is, small z is like variation of load. It varies between S and H.
Yeah, it is mentioned at the bottom of the figure also.
Yes,
Note.
yes,
There's a
yes.
note given. Like this.
Maybe I take this opportunity to, as rightly earlier highlighted by Dr. Abhay Gupta, that SCRC he conducts this capacity building courses in wind engineering. So this year also we are planning. So maybe you can, I mean, like watch our website, acrc.res.in. That is the website, so that you can monitor, so that you get to know when it is scheduled.
Great.
It will
Dr.
focus on whatever the points we are discussing. Yeah.
Yeah. Dr.
And the
Subramanian is
second
saying
one
in
is
the next
the
page.
crossing. Yes, crossing
On the
spectra.
next page, 48, page number 48, GR and GH formula should 3600 be replaced with 600 here itself.
Yeah. So the implication, no, I didn't get. Can you repeat, sir?
So there are two expressions here, GR and GH on this page.
Yes, sir.
So there is a 3600 value given there.
Yes.
So Dr. Subramanian is saying, should we replace them with 600?
See, as I highlighted earlier, the mean wind speed definition, different people use 1 hour or 10 minutes. 10 minutes means 600, 1 hour means 3600. Since IS code is reference is 1 hour, that is the reason we are using. Whereas if you take Australian code or some other codes, 10 minutes reference will be there they substitute 600 seconds.
So he's saying that the equation for MC in Australian New Zealand 1170 is completely different than IS 875 part 3. MC
Yeah,
is this crosswind, a crosswind design peak base bending moment.
yes.
Here, just
Uh,
here on the same page. This one.
yes. Yeah. So if you see below that formula explanation where PB bar, there is one parameter,
Yeah.
PH bar.
Yes.
Yes. So if you see that Australian code, they have shifted PH bar to PH. PH is 3-second gust wind speed. So it is both the formulas. If you take this formula, it is earlier version of the Australian code, where Australia code is also again 1 hour only taken as the reference. So it is borrowed from that, and we are maintaining it. Whereas recent versions of Australian code, people are not properly substituting it to minimize these confusions. They have decided that they will remove the P bar H. In place of P bar H, they will put PH. So when you put PH, there will be a denominator correction factor will be there. So pH divided by that correction factor will lead to pH bar. So basically we are coming back to same nose, whether I come this side or I come from behind. So we are
Okay.
arriving at the same magnitude.
Okay, we go back to the Excel. There was one point here in the code itself for which we open that crosswind force spectra diagram. Below this. Yes. So how to get the value of CFS here? Now for CFS, you need to calculate this V bar H over FCB.
Yes.
This is called as
Reduced velocity.
Reduced
Yes.
velocity. Non-dimensional velocity.
Yes.
And you can very well see that for this particular shape, 6:1:1 or 9:1:1, which is practically a square, tall square cylinder, there is a peak which is seen around 8. If you see on the x-axis, there are two 6 typed, but actually the second 6 is 8. So around 8 there is a peak. This is the resonant. Yeah, here. Around 9 it is peak, which is resonance occurring. Across wind phenomena is largely governed by the vortex shedding frequency. So that varies with the building face width, the plan shape, and the dimensions. It varies with that and the height. So like here and the lower figure, the second one next. Here if you see, in case of 6:1, where the wind is coming on the wider face, there is a definite peak at around 9 again. But in case of a narrow long after body cylinder, in this 6:12, if you see, it is narrow face and there is a tail of the structure which is going, where there is a possibility of reattachment of shear layer. Am I correct, sir?
Yeah. Yes, sir.
And maybe because of that, the peak is not seen in this CFS curve in this wind range. So these are specific to the structures. If your structure is close to these geometries, then only you can get a rational assessment from these charts, the CFS
Yes.
value.
Yes.
If our structure is different, then the values would be much different. And then wind tunnel testing is the best solution, which should be taken up. Okay. Anything else you want to add, sir?
Yeah. So these are specific to those geometric proportions of the buildings. So other than this means these values are not recommended, even though bottom it says that you can interpolate for certain cases. So again, it is on the logarithmic scale basically. So there are some, these curves are already put in polynomial equations in Australian code. So those formulas represent these curves actually, polynomial. So you can reduce the whatever on graph physically trying to interpolate means it may be errors are can come inside. So whereas the polynomials equations substitution will minimize the mistakes.
But using the database is more rational, available database of
Yes, yes. Future is we are going to future is going to towards that only,
that
because
only.
this is the crosswind and torsional spectra. They cannot be generalized.
Exactly.
Unlike along wind spectra,
Yes.
they could not
More
be generally
defined behavior.
predicted. Yes, so that is the reason American code very wisely they said that we don't recommend you approach the literature.
So somewhere in the code we have to add that word of caution. Abhi hai
Yes,
nahi.
yes,
So people are
yes,
blindly following this.
yes,
Okay.
yes.
Thank you. We go back to the Excel sheet. Next page.
So there is one comment by Harshal Goyal that KJ die hourly mean wind speed, terrain category
Mhm.
1. Yes, it is. He rightly highlighted that it's a typo actually. The one supposed to be
I. It should be I.
I, I.
I think that was corrected in the amendment.
Uh, Two amendments came actually.
Yeah.
I'm not sure it is covered in any one of those.
Yeah, it is I. It is not one. That is
Yeah.
typo.
Yes. Yes.
Okay. Wind tunnel report reading that will come into the guidelines. What are the important points need to be reviewed in comparison of result? Again, that will be the separate thing. As per code, what should be the process of wind tunnel testing? Again, that will be beyond the codal revisions. Behavior of structure. What is the damping ratio to be considered? Yes. What is the damping ratio to be considered for wind analysis for RCC structure?
Yes. So already code is giving a table. So if you go back to code that adjacent pages, go
Upar,
upward. Yeah,
upwards.
previous pages.
Such
No,
damping.
no, 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 no. Very same location, but one or two pages only.
There's a table. Next.
So next, so next page. Yeah. So
Next.
this is the
Yeah.
table given. So what should be kept in mind about these coefficients is that this damping coefficient is not a constant for a structure. It is depends on the magnitude of vibrations. So higher the wind speed, higher the vibrations. Lower the wind speed, lower the vibration. And under high vibrations amplitudes, the damping values will be higher. Whereas at lower damping vibration levels, the damping magnitudes will be less. So if you look at this table, these magnitudes are meant for design wind speed level loads, those levels. But if you come down next page, for example, next page, yeah, further down, yes, further down. No, no, I think it has gone. Sorry,
Upar.
I'm
It was
sorry.
just above.
I'm sorry. Yes, yes, sorry. Yeah. I'll stop it. So if you see from the tops, this for computing the peak acceleration
Yeah.
paragraph on the right hand side,
Hmm.
5 year mean return period accelerations. So 5 year mean return period leads to lower wind speed. Lower wind speeds means lower wind loads and lower vibration levels. So that is why reduced value of damping is recommended there. So if your focus is on acceleration calculation corresponding to lower return period wind loads, then the damping magnitudes are less. So whereas design wind speed level, the magnitudes will be on the higher side. So caution should be adopted when you are substituting the damping values.
Correct. While in case of earthquake, it is all 5% now.
Yeah, earthquake design philosophies are different. Basically,
Because
the
into the
building will
non-linear.
undergo a lot of damage, or hinges will form. Once hinges form, it will reach 5% damping level.
Yeah. So there it
So
is
that is not
5%.
applicable here. That is not applicable here.
So there has to be a different analysis for wind and different analysis for earthquake.
Yes, sir.
Same
Yes,
model
yes,
cannot be used for both. Same
yes,
thing happens with the time period also. The time
yeah.
period calculations as per IS 875 part 3 and as per IS 1893 or as per IS 16700, there are differences. And certainly the time period in case of earthquake would be larger. In case of wind being elastic, the time period should be smaller. Correct.
No,
I'll just take an
actually
example.
we have to see this way that the spectra we call it as let us say wind spectra is there and earthquake spectra is there. So academic purpose they will plot both the curves on the same graph. So what can be noticed is that if I put x-axis is frequency, so there is a always the what is that we call that my left is your right basically. So this time period and natural frequency should be kept in mind. People misuse that synonymously they use time period and frequency. So in wind engineering, we generally put x-axis with reference to frequency, whereas in earthquake engineering they put x-axis with respect to time period. So frequency is inverse of the time period, and time period is the inverse of the frequency. So that should be kept in mind. And suppose if I maintain x-axis is frequency, and if I plot both the wind spectra and earthquake spectra, then what will happen is that earthquake spectra locates on the higher frequency region, whereas wind spectra lies on the lower frequency region. So tall buildings will have lower frequency, natural frequency, whereas low-rise or short buildings, they have higher frequency. That is the reason low-rise structures are vulnerable to earthquake loads, whereas tall buildings are vulnerable to the wind loads. That is the reason.
But while calculating the time period in case of the software analysis, the value of the time period, if you calculate with IS 875 part 3, go to that section of IS 875 where the time period calculations are given. Just above this section 8. इसके ऊपर होगा, ऊपर होगा, अबो गो अप. No, sorry. Interference, tall buildings, dynamic effect. Yes, this yes. इसको थोड़ा बड़ा करेंगे.
So, sir, these are more like a thumb rules basically. When the calculators are not there or the tools are not there, but still people are, maintaining these clauses actually not supposed to be. So there are more, what do you call, sophisticated expressions are coming up. Even earthquake code or seismic loads code IS 1893, they have also got additional formula. If you come down, there is additional formulas are also there within the same code. So these are all more like a thumb rules basically. These formulas are more like a thumb rule. So very minimum the information is substituted here. Just H and D, 2 parameters. In reality, I don't expect that only those 2 parameters will govern the time period calculation. So there are many other aspects will influence my time period. So that is more reliably obtained by doing the finite element analysis. But again, finite element analysis, we need to give certain inputs. One of the inputs is the what is the Young's modulus of the material. For example, reinforced concrete, which is a composite structure, the Young's modulus is a wide variable parameter. So there is a lot of uncertainty or real values. If I do detailed finite element analysis for a tall building, I end up with a frequency. Tomorrow I construct that building, and if I put an accelerometer and try to estimate what is the frequency, I don't expect it to match with the finite element value. So reality is that Young's modulus is one of the variables. Another variable is the effective cross section of the stiffness. So stiffness and Young's modulus both play a major role in the estimation of the natural
One more
frequency.
thing.
Yeah.
One more thing is that in the wind behavior, wind response of the structure, section more or less remains uncracked. That is up to the limited cracking, not like the earthquake. So you get
Yes.
more or less a very gross cross-sectional area. Means you are able to put in the software model, FEM model, all the masses. We are able to put
Yeah,
all
but
the masses.
what is should also be kept in mind is that in reality, lesser cracks, yes, it is there over the period of time, life of the structure. It undergoes a lot of ambient loading conditions.
Again, yeah,
So yeah, so we need to keep the life of the structure also in mind. So generally now design practice is that they don't stick to single time period. So they take plus or minus. Let us say I estimate using finite element analysis. I end up with a value of, let us say, zero 0.6 hertz. Our time period is 1.5 seconds. Then in that case, what is done is that 1.5 second is taken as a range. So plus or minus to 1.5. For that range, you do 3 cases of load estimation, and then you do the structural analysis for many load
correct.
cases, basically.
But when we
So
go
you
for
are
tall
trying to
building,
basically we are trying to address keeping the life of the structure in mind. Various possibilities are possible in the during 50-year lifetime. So we should anticipate and envisage and find at the beginning of the design stage. See, if my knowledge is more, I'll be more cautious. If suppose my knowledge is limited, I'll be ignorant. So I'll be doing things with ignorance. So there is a difference between these two
when
cases.
for tall buildings IS 16700 is being used, it gives some expressions for the time period. Now it doesn't say that what will be applicable for wind and what will be applicable for seismic. It
Yeah.
says for both. But then it writes one more statement that if a rational modeling, finite element modeling can be done, incorporating all the inherent stiffnesses of the structure. That is one of the question mark, because
Yeah.
all the stiffness are not modeled while modeling on FEM. And that is where when I was collecting on the last meeting also, when we were discussing that empirical relations incorporate all those things. When I had a discussion with some of the IIT professors who are involved in 16700, so they were also saying that actual stiffness is more than what you actually model of the structure, and therefore these empirical relations are the upper bound for that, the lower bound of the time period for that, both this formula. So in my opinion, there should be a different time period for the wind analysis and different time period for the seismic analysis.
Yes,
So
yes, yes.
maybe we can elaborate a little more on this time period calculation in the code, because this is one of the very important parameters. That is my
Yes,
point.
yes. Yes.
Thank you. Yeah, we go back to the Excel sheet. Uh, Saransh is asking, please explain effect of wind on time period as we relate for seismic analysis. I think Saransh, we just discussed this point. It is not covered in the amendment. What are the minimum criteria except for height of building for conducting wind tunnel testing? No, there are more criteria. Wind tunnel testing should be conducted for height, any geometry which is not covered in this code. See, this code is only for some prismatic simple structures. Okay. regular. But nowadays, you see the architects are not producing simple buildings. They are producing some fantasies. So all those should undergo, irrespective of height. Even a low height, a small height building, where there are designer facades and all that, you need to go to the wind tunnel only. You cannot calculate using the IS code those values. IS code can give you just preliminary guideline for initial values, but ultimately you have to go to the wind tunnel. Dynamic analysis is required for buildings and structure with natural frequency in first mode. Is there any modeling criteria to evaluate natural frequency? We discussed that. Yes, you can model as much good as you can model. The only thing is, as Dr. Rickner says, you should take into account the stiffness modifiers also. Means the cracked, the reduced gross cross-sectional area, particularly in case of seismic. Maybe we'll try to elaborate here, and we'll also suggest to the other committee that some more elaboration on time period calculation is required. Okay. I have a doubt in calculating wind load for industrial shed. My senior taught you avoid wind calculation in section. Wind load calculation direction stat pro. If I do automation, we'll discuss it separately. Not a part of the codal explanations. How wind acts as on monoslope roof. It is there. There are some very good charts for monoslopes. If you have some specific doubt about which some particular chart or table, you can write separately to us. You can separately write on our group also, and we can surely address that. Recently, earthquake occurred in Burma and one tall rise building. I don't know how it caused damage. Sorry, not the purview of this discussion at least. I said SQVe provides limited guidance on the use of internal testing. We are coming out with a whole new document, but there is a caution word note is there, which is sufficient. Anything which is not covered in this code has to be tested. Wind load on rooftop solar panel. Yes, you can inform Dr. Harikrishna. Some work on rooftop solar panels is there.
Yeah, actually, yes, there is a requirement even for ground mounted solar panels is also one of the things. Whereas rooftop solar panels is very another side of the spectrum. So this particular thing requires a lot of internal investigations. But as of now, American code already have a very good clauses available for estimating wind loads on rooftop solars. In fact, I also used it very recently for a particular case study. I referred that code, and then that code is available in the public domain. You can download ASCE 7, latest version, whichever is accessible, you can download it. So there a clause is available, and I find it comprehensive. So sometimes we can borrow information which is comprehensive in nature.
Great. There are much of concern, and there are good documents available, and we are trying to bring into the.
And for the ground-mounted solar panels, very recently Australian code introduced one clause. In a similar way, we want to also include in IS code.
Okay. Next page. Which method is perfect to apply the wind force in E-types? There are two types, pressure coefficient and force coefficient. What is the correct procedure to adopt wind load case? How to take wind? Yeah, Dr. Krishna, you may please throw light, and then I will also explain.
Yeah. So if your interest is designing a component of the building like a wall material or something, then pressure coefficients is
Like
recommended.
façade.
Yes, sir. So pressure coefficients, again, there will be like external and internal. So that facade can be subjected to from outside external pressure and from inside internal pressure. So a difference between these two is the net load acting on that structural component like a wall or the facade. But if I take as a whole building case, then the load estimations are done using the force coefficient.
That is a figure 4 approach.
Yes. So in the new revisions, all these coefficients will be updated.
Okay. There is one more point I would like to add here. While working on several projects, we have interacted with the consultants and other people, and the software people. They are all applying the story level wind force as a single point load on the this center of the diaphragm, which actually is not the correct case. Wind acts on the exposed face of the building. Wind never acts on the center of the diaphragm, center of the rigid diaphragm. So, in my opinion, the wind force should be applied at every story level as we do, but distributed across the width. It is also written in the code. Can you open that figure 4 and around that force coefficient part? थोड़ा ऊपर जाएंगे. Go up.
No, these are pressure
No, no.
coefficients.
Yeah,
You have to count
figure
them.
4.
Okay.
Search for figure 4. नीचे होगा, I think, or force coefficient you can say. It should be FIG4. No, just go to page. Either this one. So go up a little. Just a moment. थोड़ा सा ऊपर करेंगे. I highlighted that in my. No, there itself. Force coefficient. Here it is mentioned overall for rectangular buildings shall be given in figure 4 and for other buildings. थोड़ा और नीचे करेंगे. Page down. Just a minute. This section, there is a mention here that whatever force is there is to be applied on the windward face only as calculated from this. I'll get that and post on the group. I'll highlight that. So whatever force you get from this figure 4, depending on the height, width and other ratios, that should be applied on the windward face width of the building distributed across. When I discussed with the wind tunnel people, Dr. Suresh Kumar also, he said, no, it can be applied as a single point load also. The software people, they say, for the convenience of the user, we have given as a single point load, but you can also apply as a distributed load. Then wind tunnel people also agreed that if you want it like a distributed load, we can do from our calculation. We'll have to do a little bit of more calculation, but
Yes.
that is all okay. Because ultimately, when they calculate the base forces using high frequency force balance or even using the high frequency pressure integration, ultimately the wind tunnel experts, they can compute the story level wind forces, whether to be applied as a single force on the diaphragm or across the width. So in my opinion, because the face is exposed and it is mentioned also here, I'll just find out that I'm not able to see it right now, but I have read it well. So I'll find out that and post on the group that it should be applied on the windward. So this is my opinion about the application of the wind force. So go back to the Excel. The question was, so as Dr. Krishna explained, pressure coefficient is to be used for cladding, facade elements, localized, or maybe some non-structural attachment is there in the building. For that also it is good. But otherwise, for the building as an overall building, structural frame, and the foundation, force coefficient approach is the best. How to take windward and leeward coefficient in E-tips? There's nothing like that. You have to apply it only on the windward force, the overall force. That's an overall force coefficient. How to apply wind on column for grid structure? Same way as any other structure. Want to gain knowledge? Likely to discuss on that day. Wind drag force, cantilever canopy. Next, please. I think rest of the questions, whatever raised, we'll go through once. If there are any relevant to be included in the code. But in summary, I like to add here that current wind code, which is in practice, lacks in the input from the users. Basically, whenever we take up an exercise for codal revision, one source is the updation of the knowledge, the information that is obtained from various national and international sources. That is what the code committee tries to collect. Whereas at the same time, there are consultants, there are field people who are sitting in the code committee. They expect that when this code will be shared for the wide circulation, then you must give your inputs that these are the difficulties or these clauses are not clear or are ambiguous and we need more clarification. Or even like this particular session, I requested Bhavin and it's organized, and we are fortunate that Dr. Krishna has joined us, that at least let us sensitize people who are using this code in their structural design to highlight the point. So we are getting some very good inputs. But friends, continue to pour in, continue to write to us that these are the points, because this code revision process will take few months still to reach to the wide circulation draft. And in that period, we will be happy to have more and more inputs and make it a bigger one. Let us make this document a bigger document. Nothing harm in that. But it should not leave any doubts or confusions. So thank you. And Dr. Subramanian is writing codes are becoming complex and the designers want simplified codes. Very correct, sir. The way IS 456, 1893 are being upgraded, revised, whatever I say today, I was there in 456 committee meeting discussing the P draft comment. This was the fourth or fifth meeting where we are only discussing the P draft comment. It really has become a research document. I don't know how good practical field people would be able to use. But for that matter, IS 875 is quite comprehensive and simple, and the handbook is really providing good information. We also have come up with the solved examples and we will update those solved examples. Maybe we can add some more examples in that. So that way, but whatever is missing from this code as far as international practice is concerned, we will try to add with the help of all the input from you all. Dr. Harikrishna, your concluding remarks, please.
Yeah. So I just want to acknowledge that codes are becoming complex, so they should become simple, but they should not be too simplistic also. So there must be something like a balanced location simplification we have to reach. So that simplification, I completely agree that the concepts are need to be if we are well good with the concepts, which most of us are lacking in practice. So that makes the equation looking very complex. But once your understanding is there, I'm sure the equation becomes like a easy to substitute. So we cannot make such a complex phenomena too much of simplification. So that may not be preferred. But at the same time, yes, as much as simplification it has to be made. But in the process, yes, it's like a kind of effort needed is from the other side to formulate these guidelines. Is a lot of responsibility is there that I want to acknowledge. So we want to do a responsible job so that at the end the users do it with minimum mistakes or minimum wrong interpretations. So that is the goal. Thank you.
Yeah.
Thank you.
Okay, so our aim was to sensitize everyone for the wind engineering, right? And I think this session would definitely serve that purpose. And we'll request all of you, all participants, to keep on sharing their doubts, queries through email addresses or through the medium which we have created. And then we'll be keep on sharing this comments to Dr. P. Hari Krishna as well as to Dr. Abhay Gupta. Yeah. Okay. Okay. Is that?
Yeah, sure. It will be simplified and usable, surely.
Yeah.
But as Dr. Krishna said, it should not be too simple.
Yeah.
Thank you.
Yeah. Okay.
Yes.
Okay. So with this, we are closing this session. Yeah. Goodbye.
Thank you.
Yeah.
Thank you.
Okay.
Thank you, sir.
Most welcome.